In number 1, we want to find the volume of a solid of revolution formed by revolving the area or the region under this curve and above y equals 0, that is above the x-axis, about the x-axis. All right, so here's the picture. Y equal the square root of 25 minus x squared is the top half of a circle. All right, the top half of the circle, x squared plus y squared is equal to 25. The radius is 5. And so we're revolving the region from minus 5 to 5, this entire region, about the x-axis. Let's write down the formula for the volume. We're using the disk method. So the volume is the integral of pi f of x squared dx from a to b, in this case from minus 5 to 5. All right, so let's fill in our particular interval. We'll take pi out of the integral, put it in front. So you have the integral from minus 5 to 5. Square root 25 minus x squared squared dx. Okay, so this is equal to pi, the integral minus 5 to 5, 25 minus x squared dx, after squaring that square root. So now we'll integrate using the power rule. So here we have 25, well, let me not forget this pi on the outside, and then we have 25x minus x cubed over 3. And we're going to evaluate this from minus 5 to 5. All right, so let's substitute in 5, and we have 25 times 5 is 125 minus 125, that's 5 cubed over 3. And now we'll substitute in minus 5. So we have minus 125 plus 125 over 3. All right, so let's just do this calculation. So this is equal to pi, and we have here we have 125 plus 125. Okay, so that's 250. And here we have minus 125 over 3, and then because of this distributing this minus, another minus 125 over 3, so it's minus 250 over 3. So that's equal to pi times twice 250 over 3, or 500 pi over 3. And like we mentioned in class, the solid that we get when we rotate this semicircle is a sphere. And let's remember that the volume of a sphere is equal to 4/3 pi r cubed. In our case, r is equal to 5, so that's 4/3 pi times 25 cubed, or that's times 125. And 4 times 125 is 500. So again, we get 500 pi over 3. So that's just a check using the formula for the volume of a sphere. Number 2, we want to revolve the region that's bounded by y equals square root of x from y equals square root of x and x equal 1 about the x-axis. So let's draw a little picture. So here's y equals square root of x. This is the line x equal 1. And we're revolving about the x-axis. So here's the region that will be revolving about the x-axis. So we're going to use our formula for the volume. So we have integral pi f of x squared dx. And we're integrating from 0 to 1. Okay, so in our case, we're going to integrate from 0 to 1. F of x is square root of x. So this is simply x dx. Let's integrate with the power rule. And now we evaluate, we just substitute in 1, and we get pi times 1/2. And when we substitute in 0, we get 0. So here's the volume. In number 3, we're looking at the region under y equal minus x squared plus 4 between y equals 0 and x equals 0 and in quadrant 1. And this time we're revolving about the y-axis. So let's look at this. So first I'm going to draw the region. So here is y equal minus x squared plus 4. And we're looking at the region bounded by this curve at y equals 0, that's here. Y equals 0 is the x-axis. And x equals 0 right here. And in quadrant 1. So this is the region that we're talking about. But this time we're revolving it about the y-axis. So let me just draw a little arrow like this. Revolving about the y-axis. So what we're going to do is, instead of imagining our rectangles that are spinning around, instead of imagining them as sitting on the x-axis, they'll be sitting on the y-axis like this. Okay, and spinning around in this direction. So we're going to have a dy integral, or an integral with respect to y. And we're just going to change everything over to variable y. So let's take this equation and solve for x. So here it's solved for y. We're going to solve for x in order to express this curve in terms of y. All right, so we have, let me just put the x squared on the other side. Okay, put the x squared over on the left. So we have x squared is equal to, and subtract y, 4 minus y. And now square root both sides, and we have x is equal to the square root of 4 minus y. So when this is the positive x side to the right of 0. So over here, x is positive, and over here, x is negative. So when I took the square root, I only took the positive square root, because it's this side of the curve that is bounding our region. All right, so this is our function now expressed in terms of y. And so we're going to have a y integral. So we're going to integrate pi, all right, this function squared, to get our volume. And the limits of integration are going to be on the y-axis, not along the x-axis. All right, because we're doing everything in terms of y. So the limits of integration are 0 to 4. This is 4 up here. 0, 4, y is equal to 4. So we're going to integrate from 0 to 4. Okay, so let's do this. Square, and we just get 4 minus y dy. Okay, and now let's integrate 4. We get 4y. And integrate y, we get y squared over 2. And we're integrating from 0 to 4. So here, substitute in 4, we have a 16 here, minus 16 over 2. And substitute in 0, and we have 0. All right, so here we get pi minus 8, sorry, 16 minus 8, or 8. So this is a volume of 8 pi.